Hello friends, welcome to the solid design principle in C#. In this tutorial, we will see Liskov substitution principle and how we implement this Liskov substitution principle in C# and how it is useful for our application. In the previous tutorial, we have seen open close design principle. So I recommend you please go to the part 3 of this tutorial series and see like how we implement open close design principle in our C# application, because we are going to work with the same example which we have implemented in the previous tutorial. So as per Liskov substitution principle, basically it is introduced by Barbara Liskov, and as per Liskov substitution principle, like a class object in an application should be replaceable with the instance of their subtype without changing the correctness of the application. It means like if we are going to create the object of that particular derived class, then the logic should be as it is without making any changes into the base class. Or what we can say, like class A is a subtype. Suppose class A is a subtype of class B, then object of the class B may be replaced with the object of the type class A. So that is the Liskov substitution principle. So for making a Liskov substitution application principle in our application, so there are some guidelines which we should follow, so that basically take us to making a good Liskov substitution principle application. So there are some implementation guidelines, like while implementing new functionality or new exception can be, so basically like if we are going to create any new functionality, then no new exception can be thrown by subtype unless they are part of the existing exception hierarchy. So that is the first guideline and important guideline. And the next is, according to this principle, we should also ensure that end user should not know which subtype they are calling, and they should depend only on the result. So that is the another guideline. And the last one is like new derived class just extend without replacing the functionality of the old class A. So these are the some implementation guideline of the Liskov substitution principle. So let's understand this principle with an example. So go to the Visual Studio. So this is the example which we have implemented in the last tutorial. So what we have implemented, we created one abstract class to make it as a open close principle, and we had created two classes based on like permanent employee and temporary employee, and we are inheriting this employee abstract class. And basically when we are calling the base derived class, and we are printing the employee name and the bonus as per them. So basically like it is here this Liskov substitution principle says like derived class should be substable of the base class. So like when we run this application, we can see the output is coming like a name and the bonus, and here we are calling like from the base class we are calling to the derived class. So here we are following the partial Liskov substitution principle. And why we are saying partial? Because there is a one more guideline which we have seen, like while implementing new functionality, no new exception can be thrown by the subtype, or we can say by the derived class. So basically according to this structure, we may get a exception from the derived class. So let's take another employee, and that is the contract based employee, and basically for that contract based employee there is no bonus. So in that case what will happen, if we will implement this one, so it will give a exception. So let's implement that. So for time purpose I have already created a class, so let's put it here the code. And here what we have done, like we are calling the contract employee, like we have created this class and we have inherited from the employee, and here like for this contract employee there is no bonus, so we are throwing like no throw new not implementation exception. So let's call here. So I'll copy this one, and here I'll take the object 3, and instead of temporary I will call the permanent class which we contract employee which we have created newly, and here I will write contract employee, and I will copy this one, and from here I will call this. Now let's run this application, and we will see like it will give the exception for the like contract employee, and we can see like this method or operation is not implemented. So basically it is giving the exception, and it is breaking our Liskov substitution implementation guideline. And what is that, like new functionality which we are going to implement, that should not give any exception. So let's make this full logic into the Liskov substitution principle. So there will be some modification which we need to implement here. So let's do all those changes. So for making this Liskov substitution principle, what we will do, we will create two interface, and in that interface we will take function for this calculate bonus and the salary. So let's create two function into our application, new item, and here I will create the interface, and the interface name I will give like I employee, and here I will take to calculate the salary. So let's copy this one from here and paste it here. So that is the one we have implemented here, and we know like for the interface we can implement the properties, and if there is any function, that will be the declaration, not the implementation. So that is the first thing which we have implemented. Now we will create another interface for calculating the bonus. So let's add that another interface, and give this name as I employee bonus, and here just take one function called employee bonus. Here we have implemented this thing. So these two interface which we have created, one is for like getting the name and the employee salary, and another for getting the calculate bonus. So after creating these interface, now let's inherit these two interface into the abstract class. And here like what we have to do, we have to make a function public abstract decimal, and let's give the declaration for this get employee salary here. And now next what we have to do, like here it is giving the exception because we have to give the implementation for this get employee salary. So give the implementation for these two function inside the all the type of employee. So for giving the implementation, public override decimal, and here we have to give, and let's calculate the salary for the particular employee. So return any like 25,000 salary. So that is the implementation for this, and same implementation we have to do for all type of the employee. And here let's return 20, and here let's return the 20,000. So that's the thing. And here like for we know for the permanent employee and the temporary employee, the bonus and the salary will be applicable, but for the contract base of employee, like there is no this calculate bonus. So instead of inheriting this complete employee, what we can do, we can inherit the I employee, and for this one no need to implement this base class, because here we are calculating the bonus, and this interface does not contain a definition of this calculate bonus. So we can get rid of this from here. So that is the first thing which we need to do. And let's get rid of this override, and from here base class. So these are the implementation, and next what we have to do is we have to implement the property for the name, and inside this we have to assign the name value. So this dot name equal to name. So that is the implementation of this contract employee. So that we have done, like we have implemented all the classes. Now next thing what we have to do, we have to manage here, like, so now currently we can see like it is giving the exception compile time error, basically called can't implicitly convert this contract employee to the basically employee. So in this one we can't do that. So let's do some modification here as well. So currently we can see here on the program class, we can see like here it is giving a compilation error. And why it is giving? Because we are declaring it using the employee class, and we can see here like it is not inherited from the employee, and it is inherited from the I employee. So we have to make some modification to this. So let's do all the changes. So what I will do, I'll get rid of this code, and we will redesign the calling of this employee class with a different way. So I have already have that code. So let's put it here, and we'll see like what is the implementation of doing it. So currently, like what we have kept, instead of calling with the object, I have created a one class list of this employee class, and we are adding like which class we are going to call, like permanent employee and the temporary employee. And we can see like if I will enable for this contract, it will give the compilation error because it is not inherited from the employee. So let's comment this line, and in this way we are printing expected result, like how we want the data. And next, for separately we are doing for this contract base. Here what we are doing, instead of the employee, like here we are making a list of employee. So instead of the employee, here we are doing for the I employee. And like now this I employee indirectly is inheriting from the all these classes, and we can see like this contract base directly inheriting from the I employee, and this temporary employee is basically inheriting from the employee. And when we go to the employee, we can see like here it is inheriting from the I employee. So like based on that we can implement this thing. So now let's run this application and see what is the result we are seeing currently now. And we can see like here it is giving the result expected as we wanted. So this is the way of doing and implementing the Liskov substitution in our application. Like as per the guideline, we know like what is the Liskov substitution is like. It while implementing the new functionality, should not be any new exception should come. So in that way we modified our this application, like instead, because previously we have seen like when we were creating for the contract employee, it was giving the error for the calculate bonus. So in that way we have enhanced it, and we created using the interface and the abstract class. So based on this, if you have any question and doubt, please comment. Thank you.